Welcome to the CFD course, and in this section, this is the continuation of the sudden double contraction pipe. And in this section, we are going to analyze the results in CFD post. So basically, this is a post-processing section on these two files we have created as a coarse and medium mesh file. And you can import the results into the new CFD post session. And that can be, you can take it from this toolbox, and this is the result part, and the same is as we can see in the cells A6 and B6. So if you want to analyze results in the CFD post inside the Fluent, you can do it. If you don't want, then you can just click on the connection and put data inside this cell C2 and double click here, and this will open CFD post. And now we have CFD post is open, and it's always a good idea to set up the things, means that you create all the contour plots, vector plots, path lines, any XY plot, any corner data on the some location that is in the some numbers. So do them on the one case, and when you want to compare two cases, so just take the connection from let's say solution of A5 cell for the coarse mesh and put it on also on the same CFD post, and in this way you can compare two cases side by side. And because we have already done these all processing on the one case, the second case will just fit into that setting, and all the required parameters like the pressure contours, velocity contours, and section planes, they all will be generated automatically for second case as well. Therefore, we are going to apply that thing on the one case, and if you want to see the geometry, you can tick mark these parts here, and from here you can also change the properties of these surfaces. Let's say we have the wall 90 degrees band, and this is over here, this one. If I double click here, and in the render, if I click on the show mesh lines and click on apply, I can see the mesh lines on this geometry. And if you want to hide the faces, so it will only show the mesh lines. And also we have the line width as a 1. If you want to thicken these lines with more thickness, you can put the line width 2, 3 or 4. And by default you can define the color, mesh color, which is black right now. You can define your own color, right? For example, you can define as a green color, you can define cyan color, pink color, orange color, red color, but I would prefer black color because they give me more proper visibility of meshing and geometry. And now we just hide them from the screen because I want to display contour plots on these surfaces, so if they overlap, so we might not be able to see them properly. And now from here we have these contour option, and you also can insert the contour plots from here. We have the option for the insert location for point, line, plane, volume, vector, contour, streamline. And for the more details about these functions, I would recommend that you should go to cylinder problem, where I explained this CFD post in very high details. And now from the contour plot, we set the locations. These are all walls I want to display data on, and keep the range as a local or global because we are selecting all the boundaries, so local or global doesn't matter at all anything. And click on apply, and now we can see these contour lines. And if you want to change the view of these contour lines, you can show the contour lines in the required color. And for example, I would prefer black color here, and you can see here. And if you want to put the more contour lines, so you have to change the contour lines from by default to 11 to the more value, let's say 30, and apply. In this way we can plot the more contour paths, more contour plots in a single graph, but I would be preferring the default value of 11. And now I'm going to create a center plane, and that is from the axis surface. And from isosurface, I'm going to select the constant x location and value is 0 and apply. And for a time being, just hide this control plot, and now you can see we have this center plane, and also hide the visibility of center plane because I want to display the control plots. And you can create the new control plot and you can use the existing control plot. Let's say we keep the first control plot for the pressure on the surfaces, outer surfaces, and the second control plot I'm going to use for this new outer surface. And I plot here the pressure and as well as the velocity. And also I'm going to make a one plot for the vector, and on this I'm again going to use isosurface 1 and apply. And for time being, you can hide the contour plot too and use the symbol as a local color, apply. And for the symbol, you can use the normalized symbol, so this will make the symbol of the same size, that is we have fixed length option in the Fluent post-processing tools. And you can now put the size of symbol to the 0.18 or 0.1. So whatever size is good for displaying this data, you should set it. And still we have these vectors, they are going outside, and for that we have to make the projection to the tangential and apply. If does not work, then we have to apply some other methods, like we have the normal method, and we have the coordinate frame, and none of them is working. So maybe we can set along the y-axis, and this seems working. Okay, so maybe I can try the tangential here, and you can see from the side view they are working okay. And now as far as these symbols are concerned, they have some larger sizes, so I'm going to put some lower value in the symbol size and apply. So 0.02 is suitable size for this case, and this value is by hit and trial. You have to try different numbers here, and which number is going to give you the perfect results, you should select that value. And now you can see these separation zones here, and the flow is recirculating, and now it starts to develop again, and it's attached flow here. And as I draw the line in the Fluent part where I connected the mesh impedance study, and I plotted the different variables like pressure and velocity. So for that, first I have to create the line, and for this line, the first point, the x will be 0, y would be the 0.75, and z will be equal to 20.75, length of pipe plus that is the curvature of this band. And second point, x0, because I want to keep this line on the center plane, and this time y would be 20.75 and z is same 20.75, and click on apply. And for time being, just hide these vector plots from here, and so we have the line in the vertical pipe. And now you can increase the accuracy of your plot by increasing the number of samples here. So by default it's 10. And if you think the quality of your xy plot is not good, then come back here and change the value to some higher number, and you will get accuracy on your xy plot. And now I'm going to plot the velocity and pressure on this line, and I'm going to put the name as, let's say it's the pressure, and the location is the line 1. And on the x-axis, I can put the distance or I can put the pressure. So it's your choice. So let's say on this location, I'm going to put the distance, which is along the y direction. And on the y-axis, I put the pressure value. And now I can plot the value here. And if you want to change the display of a line, you can, from here, you can use the series name for legend. So you can put the name, for example, pressure medium mesh and apply. And you can also change the color of line. So uncheck the option for automatically generate line color and choose your own color from here. And also you can put the symbols for these plots, and you can keep your choice for the color for the symbols. And for symbols, as far as symbols are concerned, you can use from symbols, and let's say we have different options for the symbols. You can use ellipse, rectangle, diamond, triangle, and they will appear here. So you can also change the size of these lines and these symbols. It is done from chart display, and for symbol size you can increase from here, and you can see now the size of these symbols are increased. And you can also change the length of or width of the line, and now line is more thicker here. And similarly you can change the font size for the title, axis, legend, and you can also put the grid horizontal, vertical, and you can also change the width of these vertical and horizontal, minor and major grid lines. And so we can see that the accuracy of this graph is not good enough. So I will go back to the line 1, and I will change the samples to, let's say, 50. And so I can get the better graph here. Maybe you can go for the, let's say, 80. So this is, I think, better option here. And now I'm going to use the second plot here, the second mesh, and I will just put this solution cell on the cell C2 results. So just hold your mouse button and drag this one on the cell C2, cell A5 on cell C2, and double click here. And do you want to refresh this simulation? Yes. And now you can see these two lines. One is the pressure medium, second pressure for coarse. And now I will go back to the plot 1, the XY plot here, chart 1. And for data series, I'm going to put the name. And on the x-axis, the same y-axis, y-axis of pressure and line display. So we have name for this line, which is the pressure medium. And for second one, I will put the pressure coarse. In this way, we can display them on the screen. We can be very much sure that the which line representing which case. So one is the medium and second is a coarse mesh case. And if you want, you can also change the order of these results. I can move this result upward and apply. And now you can see the pressure coarse is first case and second case is the pressure medium. And similarly, you can also change the line type and the symbols. So let's say I put the rectangle for the second case, which is a coarse case here. And I can change the color of symbols also. And same is true for the line color. And let's say I put the line color for this case as yellow. Or maybe we can go for the red color here. So it's your choice. So I'm just playing with these things, and now you can see that we have. And looking at this data, I can see that there's a very small change, and almost I cannot see any major change in the results. So results are they are similar. And as I told you earlier, if you go for the final mesh, so still we get the same result. So it means that at the 4 leg nodes, we have already achieved the mesh dependence for this case. And for this case, so far, you can go with a coarse mesh file, because the coarse mesh file and medium mesh file, they are giving you same results. And so this is the working of how we can compare the cases and how we can ascertain the mesh dependence of any CFD case. And if you want to really compare that, you see some changes in the results, so you should go for the lower count. Let's say you create the 2 more meshes of 2 leg and the 1 leg, and then compare them in the same environment like you are seeing on the screen. And now I go back to the 3D viewer, and from here you can see we have the medium case. You can also change to the coarse, and here you can change to the medium case. And now I can I can hide the line from here from screen, which is shown here. And now I can plot the, let's say, control plot 1. And also if you click on this option, we will have the same view in the both cases. And second option, which is the when we log these cases from here, so we can move them in a one go. But if you release this option, now you can move these plots in this graphic display window separately, independently. But again, once we click on this option, we'll have the same view, and now we can move them in a single go. So this is how we compare the cases. So this is the plot for the pressure. And now I'm going to plot the second plot, which is the plot of the velocity on center plane. And if you zoom the one plot, this will also zoom the second plot. And in this way, you can compare these cases side by side. See? And similarly, you can also plot the vector plots on these planes. And you can compare them also. And you can see that we have for coarse mesh, we have the less nodes, and but it's still is fine enough, and we are getting the almost similar results for these two meshes. Now this is all about the CFD post processing and CFD post. And in the next section, I'm going to study about the parameterization study in Ansys Workbench for same case.